Okay, so today we're going to talk about the Windows Communication Foundation, which is basically a part of the .NET framework that was released in .NET 3.0 that allows you to perform service-oriented communication. So instead of writing your own protocols using low-level socket APIs, primitive constructs, we now have this object-oriented model that complies with CLR specification for the .NET platform that we can use service-oriented communication in. So let's actually talk about, first off, what is WCF? So I've already stated that it is service-oriented communication. So at some point in time, your WCF functionality needs to be hosted in some sort of service. Later in the example, we're going to host our service in Internet Information Services as a DLL, a class library. And it's a little bit different. We'll talk about the project templates involved in Visual Studio and things like that, because there is a slight difference between a WCF service library, which does get compiled as a DLL, and between a normal class library, which is just a normal DLL. There's a slight difference in the outputs between the two project types that we'll talk about later. So one of the key aspects of WCF is it is interoperable, meaning that just because it's within the CLR platform doesn't mean it can't be used anywhere else. WCF under the hood uses things like SOAP and serialization, text, XML. You could even configure to use arbitrary HTTP for your requests. So you can actually consume WCF from different programming languages, different constructs, outside the .NET platform, so you're not just limited to .NET and the CLR. We're not going to go into that. We're going to stay within the constructs of the CLR and .NET. But the cool thing about that is because we're in the constructs of .NET and CLR, and we have this rich set of metadata. And through the rich set of metadata that .NET provides, we have capabilities like reflection, and it's very powerful. We have all this rich set of type information about any object in .NET. And what this metadata allows us to do in WCF is we can actually consume our WCF services through normal means of writing code. We can call functions on our WCF just in C# or VB. We can define those functions in C# and VB. We can use interfaces and classes. We can actually create our own types, and we can consume those types as even return values. So WCF actually works on the construct of bindings and endpoints. And a binding actually describes an endpoint, and we'll talk about bindings and endpoints here in a second. An endpoint is basically just a connectivity point. Next, we have things like service contracts, which actually is basically like an interface. It uses interfaces most part, and this defines what your WCF service can actually do. Then we have operation contracts, which defines the methods, and then we have data members, which are maybe things like member fields, parameters, things like that. Now, WCF uses configuration. So we're going to have an app config file or a web config file in our service. The client would have an app config, and it uses the configuration sections in that called system.serviceModel is the specific section, and we'll be using that throughout the presentation to configure both the services and the clients, and we'll do that as we actually dig into the code. I'm not going to talk about the base implementation of WCF, how it actually uses serialization and how it uses SOAP and things like that. There is a WCF white paper on MSDN. If you were to go to MSDN's website and actually just search in Windows Communication Foundation, you'll actually get this page, and right on this page there's a link to read the WCF white paper, and this, as far as I know, is the full WCF specification. Talks about a lot of different things, bindings, endpoints. And outside of this white paper, MSDN has a rich set of information about, you can look up bindings specifically, you can look up endpoints specifically, and I'll include these links later in the presentation. So there's a lot of rich information about WCF. Okay, so the first thing I want to talk about is actually bindings, because a binding describes the transport, the protocol, and the encoding that's going to be used for the communication. So the transport is defined as how is the data actually transported between the client and the service. In the example we're going to use the basic HTTP binding, which uses text and XML to transport the message. Then we have the protocol, which again is just HTTP, and the encoding, encoding can be UTF, something like that, ASCII encoding, used with text and XML. So the binding that we're going to use, basic HTTP binding, it's a very simple binding. Basically, we're using it over HTTP. We're just sending arbitrary text and XML. There's no authentication required, so this is going to work with anonymous requests. So we can have an anonymous client contact the WCF service and say, hey, I need to do this, and it can do it without providing any sort of authentication or security information. There are other bindings that are provided with WCF. WS HTTP binding, Net TCP binding, Web HTTP binding, and there is a full list of these bindings on MSDN, which I believe you can find through the Windows Communication Foundation bindings page, and in this section, configuration system provided bindings, and this provides the entire list of the bindings that are out of the box provided by WCF. It also goes further into explaining what each binding is, what it does it require security, does it support sessions, transactions, duplex, so it has a whole wealth of information. Now, if one of these bindings doesn't suit your needs, you can use a custom binding and implement that yourself for a custom transport protocol and encoding. But for the example, we're going to stick with the most basic approach, which is just the basic HTTP binding out of the box. It's the easiest to set up and easiest to wrap your head around. Now, a binding describes a WCF endpoint. So what is an endpoint? An endpoint is a connectivity point, meaning it is the place that a client can access through means of an address. Maybe it's a URL, a file path, something. It is just an address to a location where the service is available at. That's what an endpoint is. And without an endpoint, you have no way to expose your WCF service to the outside world. So a binding describes that endpoint, and an endpoint specifies the address, the binding that's used along with that endpoint, meaning what binding does this endpoint support. So if we have a HTTP binding, we're not going to support, say, an FTP binding, which would have to be a custom binding anyway, and that's a bad example. But if you have an HTTP binding, you need to use an HTTP binding to connect to it. Then the endpoint also specifies the contract. So when we connect to an endpoint from a WCF service, we're saying, okay, I want to connect to this endpoint through this address, and I want to use this WCF service. And the WCF service is described through what's called a WCF contract. And we'll get to that more so when we actually start writing the code. But a contract is essentially just your interface in code, and we're going to be using attributes to specify the contracts. And we'll show that more in code as well. But it defines your actual service implementation, so it's going to describe the class, the methods in that class that can be exposed through the service. We can specify parameters, return values, composite types, so we can actually have other classes or even structures that we pass as parameters and data. You can use all that in WCF. It's just like writing normal code. Now, the example that I've actually chosen for this is going to be called routing services. And what this is going to be is a normal WCF service that's going to serve named connection strings. Now, this is a practical example because sometimes you want to deploy an application to a client computer and you don't want to put the connection string on that system. Because it has sensitive information such as your username and password, your database name, maybe you don't want that data actually stored on the file system or anywhere where someone can actually access that easily. So the advantage of a service like this is we can have a client contact our WCF service and say, hey, I need this connection string, give it to me in memory so I can use it, and then we can dispose of that connection string when we no longer need it. Now, in this service, we're going to implement our own authentication. We don't want just anybody to be able to get our connection strings, so we are going to require that a username and password be specified. But we're going to do this through the use of an operation contract, which is just a C# method exposed through the WCF service. That's going to take two parameters, username and password. And the reason we're doing this is to avoid having to use X509 certificates, which is just, it's similar to like an SSL certificate or something like that. It encrypts your information while you're sending it over your transport. We are going to unit test all of this. So we're going to have unit tests for the service as well as the client. So we'll do a little bit of that as well. And then we'll consume our routing service once we implement it. And once we host it, we'll actually go through configuring IIS to host our service. Then we'll create the client. We'll reference our service through what's called a service reference in Visual Studio. We'll use the service. We'll unit test the service. And then after we have everything done, we're going to go back and talk about dependencies. Dependencies are the app config files because you need to deploy those to your client and your server. Dependencies are the service reference in Visual Studio, which we'll talk about. And I'm going to talk to you on how to remove those dependencies and do everything in code so you don't have to manage any external files. So we're going to be using Visual Studio 2012. This is actually Visual Studio 11 release candidate, which was recently released with the Windows 8 release preview. If you haven't got it yet, go ahead and download it. If you don't want to do that, this is perfectly backwards compatible with Visual Studio 2010, so I'll have the solution files available for download after this is done. But we're going to go ahead and create a new WCF service library. We're going to start off by actually doing an empty Visual Studio solution. And we're going to use .NET 4.0, and we're just going to call this routing services for the solution. And we're going to go in and add our WCF service library, which we're going to use in C#. Now, there's two different types of WCF services you can create out of the box. You have a service library, which is just a DLL that's hosted in IIS. Then we have a WCF service application, which is still hosted in IIS and WAS, but it's managed by Windows Server App Fabric. And if you want to know more about that, go to the link that's provided in Visual Studio. I'm not going to cover that. We're just going to go with the basic approach of a WCF service library. Now, like I said earlier, there's a key difference between a WCF service library and a class library in C#, because essentially you could just create a normal class library, reference the WCF namespaces, and use all the attributes and information you need. But the difference is when you compile a WCF service library, it outputs .svc files, which I'll show you later, which you wouldn't get from compiling a normal class library. So you need to make sure that you have a WCF service library selected. And this also allows you to have some of the default Visual Studio tools they provide. You can use those in a WCF service library where you wouldn't be able to in a normal class library. So we're going to name this routing service. And we'll go ahead and create that project. Close out some of these windows here. Now we're going to do everything from scratch except for the app config file. So we're going to delete these two C# files that come out of the box as a template. Now let's look at the app config file. Like I said, there is configuration required for a WCF service. And this is actually where you specify the services in your project that you're going to expose to the outside world. This is also where you specify your bindings, your endpoints. There's also behaviors. We're not going to talk about behaviors in this session because they're not needed for the simplicity of this example. But this is where all of your service configuration information is stored. And there's actually a lot provided by default in here. We're actually going to trim this configuration file down quite a bit because we don't need all that for actually deploying a WCF service. Now the first thing we need to do is we actually need to specify the contract for our service. What can our service actually do? And we're going to do this through the means of an interface. And I'm going to call this iConnectionStringService. And we need to import two basic namespaces using system. That one's for things like strings and the primitive types and all that. We're also going to import system.serviceModel, which is where the attributes live for the WCF library. Now, to implement a WCF service, we need our interface, and we actually do this by specifying the service contract attribute. And what this attribute does is it says that anything that implements this interface is essentially an exposable WCF service to the outside world. Next, we're going to implement a method, and we're going to actually return a SQL connection string builder. And we need to actually go over here and reference system.data to be able to get access to that, which we actually already have a reference to, so we're good there. And we're going to import that namespace. And we're going to call this get connection string. And we said that we wanted to specify a name for the connection string because we want to work with names. And we also said that we wanted to do our own authentication. So we want to say, let's go ahead and make them provide a username and password. So we'll say string username, string password, and then the name of the connection string. Now we're not returning a normal string because of things like SQL injection. People could essentially inject their own parameters and things like that into a connection string. So we're returning a SQL connection string builder, which helps provide some level of security for that. Now what we need to do to expose this to the outside world is, because this is a method that we want our WCF clients to be able to call, we're going to specify the operation contract attribute. And what this does is it says just that. It says this is an operation that the outside world can use, and then we'll have some sort of class that actually implements that functionality here in a moment. So very simple service. It's called iConnectionStringService with one method that returns the connection string builder. We specify our username and our password and the name to that connection string. Now what we're going to also do is we're going to make our WCF service implement a dictionary of string and SQL connection string builder. And we'll call this connection strings. And this is just going to be a private member field that we're requiring our service to implement that stores our connection strings, because we need some place to be able to retrieve the connection strings from. Now this could be anything like a database, XML file, or something that lives on the server. For this example, we're going to do it all just in memory. So we're going to actually compile our connection strings into this collection, and we'll do it that way. Now what we're going to do is we're actually going to set up some unit tests real quick. So we're going to create a new project. This will be a unit test project, and we'll just call this routing service.tests. Again, .NET 4.0. And we'll just do Control-RR on the unit test class and rename this to connection string service tests. And then we'll rename this method to get connection string test. Again, using Control-RR. Okay. And we'll rename our C# file over here. Now what we're actually going to do is create a folder. We're going to call this mocks. And for those of you who aren't familiar with unit test mocking, this is basically a way for us to create a testable implementation of our service that we can test without actually having to reference the service itself. So what we're going to do is we're going to add a new item, and this will just be a C# class, and we'll call this connection string service mock. Now we do need to reference our library so we can get access to the interface. This will be under solution, projects, routing service. Now we're going to go ahead and implement the iConnection string service. Which I forgot to make public. Okay. And we need to reference system.data, which is not done out of the box for a unit test. Okay. And actually that is correct. We need to change our connection strings. This would actually have to be a property because you can't have fields in an interface. So what we're actually going to do is we're actually going to provide a default abstract class instead that provides some default functionality. So we're going to call this connection string service. This will be a public class, and this will actually implement our connection string service interface. And we'll actually say that this is instead an abstract method. We'll make this an abstract class. And then we'll say that we have our private dictionary of string. Okay, and this will actually need to be protected. So anything implementing the abstract class has access to the private dictionary. Make sure our library compiles, and it does. So what we're doing here is we're actually creating our WCF service. So we're saying that we have this service called iConnection string service, which defines an operation contract that gets a connection string using a username, password, and name. And we're defining a abstract class that provides some of the default information we need. So we're going to ensure that anything that wants to implement the service must implement our get connection string method. And we're doing that by providing an abstract keyword. And then we're saying also that we're going to provide a default dictionary of string of SQL connection string builder, that anything implementing this must also use. Now this may be something like a MySQL connection string builder if you're using MySQL. You could even make something a little bit more abstract like DB connection string builder. But we're just going to stick with SQL, and we'll do it that way. Now in our mocking class in our unit test, we're actually going to do connection string service itself instead, and we're going to implement the abstract class. So now you can see that we are implementing the actual method, and we also have access to our dictionary called connection strings. Now for this, we're just going to say public connection string service mock. We'll provide a default constructor, and we'll say we'll initialize that to a new dictionary, and then we'll just add a new connection string, and we'll call this default connection string. And then we'll say new connection string builder, and then we'll specify a connection string. And I'm actually going to borrow a connection string from connectionstrings.com for the sake of this example. We don't need anything special. And this is going to be, it can still be a private class. This is just the unit test. Now we're going to say if connection strings contains key, and we'll specify the name of our key. Then we'll return our connection strings and the name of the key, else we will go ahead and return null. Now we need to provide some sort of form of authentication. For the sake of this example, we're going to provide two constants in this class. Called test user and test password, and we're going to go here and we're going to say if not username equals username, or not password equals password, then we'll return null. So if authentication fails, again, this is just our unit test. So this is a mock object. We're basically mocking what our actual service would do in production, but we're using test data that we know we can test against. So we have our authentication done, we have our service done, and if it does, if everything passes, we should get a non-null connection string builder object. We'll make sure that compiles. Now if we go to our actual test, now we can actually test this, and we know that when we call this, we want to say that we're expecting a SQL connection string builder. We know that that's what should be returned from the service. And we know that that's going to be called through service.get connection string. And we know that we're going to have to provide a username and a password and the name of the connection string that we want. And that we know that we want to assert that our builder is not returned null. So now we can actually create an instance of our connection string service mock. So we can say connection string service mock service equals new. And there we go. So we have our unit test. So now if we were to run this unit test, let's first build our solution and make sure it works. Let's go to test, and then we'll open up our test explorer. We can see that we haven't run our get connection string test, and this should actually pass. And we can see that it does. So we have basically our unit test of what our service should do and should return. We have a mock of what our WCF service should do in production. And like I said, though, in production, your actual service may be connected to something like a database, an XML file, something else that might store the connection strings. For the actual service, we're going to go ahead and just do the same thing and implement a private dictionary as in the abstract class, and we'll just add a connection string to that as well. We're not going to do anything out of the box like go connect it to a database or an XML file. We're going to keep things very simple. So now that we have our service designed and unit tested, we can actually implement the real thing. So now we can go to routing service, and we could add a new item. And this will be a class. And we could call this connection. We're going to call this stored connection string service. And this will be public. And we'll again implement our abstract class. And we'll provide a default constructor. Initialize our dictionary from our class. And we'll add our default connection string, as well as our builder, and we're just going to borrow the same connection string. We'll actually borrow this whole line from our unit test, because like I said, we're not going to do anything fancy. Okay. And we can actually borrow the code from our unit test mock because again, we're not going to do anything fancy. For the sake of this though, we're going to say that maybe our password or username, let's call this routing service, and let's say that the password is ABCD1234 for username and password. And we'll just borrow the code from our unit test. Normally you wouldn't borrow the code from your unit tests because it would be connected to an XML file or maybe a database or something, so your authentication will look different, and then the retrieval of your actual connection string would look quite a bit different as well. You might have a separate method called something like this, private SQL connection string builder. And then you might call it internal get connection string. String username, string password, string name. And then this would be the actual method that actually does the work to get that, and this would only be the publicly exposed version of that method. You may even use this just to do your authentication, and then you might move this code to here, and then we could actually say else return internal get connection string, pass in the, and actually we could remove the username and password from here. So this will be something of more along the lines of what you would do in production code. You would have your public service method that takes all the parameters. You would do a little bit of validation, and then you would have some internal method that actually does the work of getting what you need and returning it. We'll go ahead and leave it like that. Normally your username and password might be stored in a web config file, something like that. Let's go ahead and clean up our service file a little bit. So we'll call this serves named connection strings. Okay, and then we'll go ahead and region this up a bit. Okay. All right. So this is our actual production service. So we have some constants, our default connection string. We have the public interface, which is the method that's exposed to the public. And because all the way down to our interface that specifies the service contract attribute and our operation contract attribute, those carry with this class. So it's still going to be an exposed WCF service. So this is our public interface, and then the actual private implementation. Okay. So now that we have our WCF service done, if we were to actually F5 debug this, let's see what happens. Now what should happen is it should actually break, and what we're going to get here is it says it can't find any service metadata. Now this brings us back to our app config file in our project. We have all these services that we've made. We have our interface, we have our class that implements that interface, we even have an abstract class. But we haven't actually configured our service in any way, shape, or form. And if we open our app config file, you can see that we actually have some references to the original files that were included in the Visual Studio project. So we have this routing service.service1. Well, that was the name of the default template Visual Studio provides. We actually want to go ahead and change this to stored connection string service. We don't want to specify our abstract class, although we could, but there's no actual functionality in that, so it's not going to do us any good. Now this design time address here under base addresses, that's actually used for the WCF host tool that we actually just ran by hitting F5. Hitting F5 on a WCF service library actually invokes some tools that comes with Visual Studio to help you debug your services locally without actually having to host them. So that's primarily there for using the Visual Studio tools, so we can go ahead and leave that, although we're going to change that from service 1 to stored connection string service. And the same thing down here for our interface. It's going to be I, and instead of stored connection string service, it'll just be I connection string service. We are going to remain using basic HTTP binding. We're not going to use WCF authentication in any way, shape, or form. Let's go ahead and remove these comments here. Let's go ahead and remove this comment here. We don't actually need that. We'll talk about this identity section later on. Now the metadata endpoint, this is actually how we know when we reference the service from our WCF client here in a bit, this is actually what exposes the type information to the client. Without a MEX endpoint called iMetadata Exchange, our client would have no way to know what types to create, what values they are. You know, is it a string? Is it a Boolean? We would have none of that information, and that's what the metadata exchange endpoint does. It's a connectivity point for the clients to say, hey, give me information about the service. Now you don't always need a metadata endpoint, especially if you're actually sharing your interfaces through a common library. You can do that, which we'll talk about later. But for now, we're going to go ahead and use metadata. So let's go ahead and delete that comment. We can leave that the same. There's no changes required. Behaviors, we don't need any of these actually, except for HTTP GET enabled. And we want to go ahead and actually leave include exception details and faults. We'll set that to true instead of false. That way we have more detailed information about what goes wrong in our service. And we'll go ahead and delete these comments. And close that up a bit and close this comment up here. All right. So we can see that our app config file, a lot shorter than it was. Nothing complicated about it. Now we're done actually modifying that. Now I want to show you an alternate method to modifying your configuration file. The cool thing about the tools in Visual Studio, and this includes Visual Studio 2010, you can actually right-click your app config file, and you can go Edit WCF Configuration. This is the same exact thing as editing your app config in the actual text editor. The difference is we get a nice user interface to do all of it for us. So if we look through this, we can see that we still have our routing service, stored connection string service. We can see that we still have our endpoints specified. We have our basic HTTP binding endpoint. We have our metadata exchange endpoint. Now we don't need any of this for the client because this is the service. This isn't the client portion of our system here. So the only thing that we're interested in is the services section. And if you go under bindings, there's nothing there. And you don't need to mess with any of this advanced stuff unless you're doing something advanced with WCF. So we can exit out of here. We don't need to make any changes, we already did, but I just wanted to show you that that tool is available. And that is one of the key differences between a class library project and a WCF service library project, is the ability to use tools like this in your WCF service projects.
Okay, so now that we have everything done, we can actually go ahead and hit F5 and run the WCF test service host. And what's going to happen is it's going to search for our metadata in our service that's exposed. And you can see that it did find our service, and we're using the design time address. You can see it found our iConnection string service. which is implemented through our stored connection string service class. Now you can see that we have an error on get connection string, and this is because we're using a dictionary of type string and of type SQL connection string builder. Now dictionaries are very hard to serialize into XML. They're very hard to describe because a dictionary doesn't just provide storage, it also defines behavior. And that's why we get this error. And the WCF test client doesn't support advanced WCF scenarios. It is a pretty basic tool, although it is useful. So what we're going to go ahead and do is we're not going to use the WCF test client. We're actually going to go ahead and deploy our WCF service to IIS in the default website, and then we'll go ahead and proceed to create our actual WCF test client. So let's close that and let's close our service. Now the first thing we need to do is we need to run IIS, Internet Information Services Manager, and we need to run that as administrator. Now I develop all my software under a standard user account, so we only elevate when necessary. So if you're already running as an admin account, you shouldn't have to enter your credentials. And I'm just going to go ahead and choose my default website. And I'm going to create a new application. And we're going to call this routing services. Let's call it routing service just to alleviate any spaces in the name. And then what we'll do is on our C drive here in www root, we'll also create a new folder and we'll call this routing service. And we'll click OK. So now we have a new application, and what we need to do is make sure that the application pool is running under .NET 4.0, and we can see that it is. It's under ASP v4, which is .NET 4.0. So now that we have our virtual application set up for our service, we can go ahead and publish this. Now we need to run Visual Studio as administrator to be able to publish to Internet Information Services. So we're going to save this solution. Oops. Go ahead and hit save all and close our application, and then we'll run Visual Studio 2012 as administrator. And I actually haven't run Visual Studio 2012 as admin before, so it's probably going through all the initial setup and configuration for the user account. And you can see that we don't even have routing services on here. These are projects from my separate account, so we'll have to go ahead and find that. Okay, so we can go ahead and hit open project, and I just have it stored on my H drive. Under routing services, we'll open the routing services solution. Okay, and we'll build. Make sure everything goes. And what you can do is you can right click on your routing service project. And we're actually going to go hit publish. This is just like actually publishing a website. We're going to go to computer. We could potentially select local IIS and then just select our virtual application, or you could choose to use the file system. Let's go ahead and try to use the local IIS. So we'll hit routing service and then click open, and then we'll go ahead and hit publish. And let's go ahead and change, we'll publish it again, but we'll publish it under release configuration. Okay, now to make sure your WCF service actually works and is accessible, what we can do is actually just navigate to that path. So let's actually first show you what is output from publishing a WCF service. So if we go to C and we go to our virtual application routing service, there's going to be a couple things here. And the first things you'll see is what I talked about earlier about the differences between a class library and a WCF service library. Is the WCF service library outputs these .svc
files. And these are actually going to be what you navigate to in your web browser, as well as specify as the address for your WCF service. Hence the extension SVC for service. Now, if we open this in Notepad, you're going to see that all it is an ASP style declarative line, and it specifies our service host and then our the actual type name to our service. So we have our root namespace routing service, and then the actual service name connection string service. Now, mind you that connection string service is the abstract class, so the actual one we would want to point to is our stored connection string service, which is the actual implementation. And we can see that we have the correct type information there. So what we can do is we can actually, I'm going to copy this name, so I don't have to go through all that. I'm just going to copy that. And what we're going to do is we're going to go to our web browser, and we're going to do HTTP localhost routing service, and then a name to our service file. And what we should get is our WCF service. If you get this screen that shows the example code and shows the blue title, you did everything right. If your service was not accessible for some other reason, then that means that something is wrong with your WCF configuration or something is wrong with your code. And you would get either an exception and a stack trace or some sort of server error. Sometimes it'll even produce a 500 internal server error on the screen. But if you get this screen, you've done everything right and your service is ready to be accessed over the web. Okay, so now that we have this, we can actually go ahead and proceed to create our WCF test client. We're going to go ahead and just go do this in the same solution. So we're going to add a new project. And this is going to be a very simple console application. I don't have an existing program that we're going to integrate this into for the example, so we'll just create a console application. I do want to say off the bat that the term WCF client is misleading. WCF client, people usually tend to think as its own process, executable, something like that. WCF client really refers to just the code that accesses the service. It's similar to using a web client to download a file or a string from over HTTP. Not a whole lot of difference. And the code to actually do all this is very simple. But the first approach we're going to take is the out-of-the-box configuration file approach. So we'll add a service reference in the project to our service, and I'll show you how to do all of that. And then what we'll do later on is we'll go back and remove that dependency of the service reference and the configuration file, and we'll do it all strictly in code. So we're going to call this routing service client. And I think that actually created a .NET 4.5 project. We just want .NET 4.0. Okay, so we have our basic app config. We'll set this as our startup project. Now, one thing I'm going to do real quick is I'm going to right-click properties on our WCF service, and we are going to go to WCF options, and we're going to disable start the WCF host when debugging another project. If I'm debugging just the client, more specifically, I'm debugging it while connecting to IIS, I don't want to also start the Visual Studio debugging host. So we're going to uncheck that because it's absolutely unnecessary. So now we can go to our program.cs and we can see there's absolutely nothing here. Let's just go ahead and clean up these namespaces real quick, and we'll import system. Now the first step to accessing your WCF service is to right-click on your references folder and click Add Service Reference. And you get this cool little service reference dialog. And the cool thing about this is we can actually go go to our web browser and copy the original string that we used to navigate to our service, and we can paste that in and hit go. And what this will do is actually discover our service in IIS. And we can see that we have our iConnectionString service, and we can see that we also have our getConnectionString method. Now you want to make sure that you're not accidentally referencing the abstract class. So here we can see that we are using the stored ConnectionString service, which actually has all of our implementation. Once you've done this, you can go down here to namespace and provide whatever namespace you want. So we're going to call this routing service. And you want to make sure that when you specify this namespace that it does not conflict with the namespace in your current application. And there are some additional features here under advanced, so let's talk about these real quick. The way this works is by adding a service reference, it is basically asking our metadata exchange endpoint on the WCF service for the metadata about all the types involved in the service. So when it talks to the service, it gets that metadata, and what's returned is actually our service contract. So it stores the class service stored connection string service, and then it returns the method get connection string. We don't have any other types involved, but if you had a composite type involved, which is basically a class or a structure that you specify as a return value or data, it would get that type information as well. And then what this does is it actually creates copies of those objects based on that metadata in your own project. So the cool thing about that is you don't actually have to have a hard reference to the library to have that type information, more specifically the actual types. The other cool thing is anytime you make a change to your WCF service or those types, you can right click the service reference and hit update reference, and it'll actually update all the type information and rebuild those types. If you want to reuse your types, more so if you would like to share your types amongst your projects and not recreate them every time, you can actually throw them in a common library, maybe routing services.common, and we'll actually go through this process later. And what you can do is reference that library from both your service and your client, and now you have access to your types without recreating them every time. Now what we're going to do is we're going to close this out, and I'll actually show you how it creates those types. So we're going to make sure we have all our information here. We specified our namespace and click OK. And what it's doing now is it's getting all that metadata from the service, and it's actually generating the types. So we can see that under references, specifically service references, we now have our routing service reference. Now this is not a hard reference to the routing service library, so we could actually still reference the DLL itself and we would not have a circular dependency. This specifically works off of metadata. Now if we go to, let's see, configure service reference, we get that same dialog, and then update service reference does the same thing we already did. It just contacts the service and updates all the metadata. Now if we double click on this, we can see that we have an object called our namespace routing service, and we can see that we have objects now. We actually have an interface called iConnectionString service. We have a object called connection string service client, and we can see that we have some constructors, things like that. Now what you can do is you can go look in your app config and you'll see that it's added some things. This is the WCF client configuration. So just like our service has a service configuration, our client has a client-side app config as well. And what this does is it specifies, again, we have the binding, our basic HTTP binding that we're going to use to connect to the service. We have our endpoint that specifies the actual address to the service. We're specifying our binding here, our binding configuration. Some of this is just default information. We have our contract, so we have our iConnectionString service contract, which is the interface that actually specifies the WCF attributes on it. And then again, our binding information and all that. So it's a very simple config file, and again, you can right click that and hit edit WCF configuration, and we could use the Visual Studio tool. And now you can see instead of working under the services folder, we're working under the client folder. Now we could select this and we could see all the metadata. We could see the configuration options. We could actually click our bindings and configure the bindings themselves. We could go down here and see bindings, and we actually have our basic HTTP binding defined with all of our defaults. And you can actually modify the behaviors of the binding here. We don't need to, but all of that is available. We could go here and see security mode is set to none, so we're not providing any sort of credentials, which is what we want because we're handling our own. All right, so let's go ahead and close that. We don't need to do anything here. And what we can do now is we can actually import our namespace using, I believe it's routing service client, or actual routing service is the namespace we had. And now we should be able to access our connection string service client. We can just instantiate a new instance of it. And you'll notice that these different constructors, although we have the defaults, we could just instantiate a parameterless constructor. We can specify custom endpoint configurations, addressing, bindings, things like that. But it's already set up, so we don't need to provide any of that. It's gonna get that information from the app config. Now later, when we talk about dependencies and we'll remove those app configs, then we'll have to specify information to the constructor. But now we can actually do SQL connection string builder, and we can do client.get connection string. And we can specify our username, which was routing service, I believe, and then we had ABCD1234 for our password, and our connection string for default connection string. And then what we can do is we can say, we'll do a debug, and then we'll say assert builder not equals null. Okay, so if our builder is for some reason null, our debug assert will pop up and tell us that something went wrong. So we could say the connection string builder was returned null because the valid or connection string does not exist. So we want to provide at least a useful connection string. Now down here, what we'll do is if we do have it, we'll just write the connection string to the console window, and then what we'll do is we'll say console.read key just to wait. Now if we run this, cannot convert type, dictionary object. Let's see what we did. We should just be returning a SQL connection string builder, which may not actually be able to be serialized very easily. So let's go look in the object browser. And some of this you have to be aware of, because some of these default .NET objects may not be serializable into something usable by WCF, and you may have to create yourself a composite type. Now we may just have to do that. So we can see that it inherits from DB connection string builder, iCollection. Let's actually go to the definition, and we can see that there is no serialization attribute applied to SQL connection string builder. So SQL connection string builder may be something we can't return from a WCF service operation contract. So what that means is that we would need to go back and change that to something that can. And this introduces us into what's called a composite type, which is essentially just a class or a structure, but it's completely serializable and usable by WCF. So we're going to have to go back and do that. Because based on the metadata that it got and the fact that it is not serializable, it's getting the incorrect metadata and it's causing some problems in our service. So what we can do is we can go back to our iConnection string service. We can actually change this. We're going to call this connection string. And there's really not a connection string object in .NET, so this is fine. And what we're going to do is specify a new class in our service project, and we're going to call this connection string. Okay. What we need to do is actually specify the attribute that says that this is going to be transported over WCF. And we need to import system.serviceModel. And then what we can do, it's actually going to be a data contract. So we're going to specify data contract, which actually lives in runtime.serialization, not system.serviceModel, which we still need, and this needs to be public. And what we need to do is the basic key components of a connection string that we're going to provide are going to be very simple. So let's go back to
connectionstrings.com. And we'll just throw this in here as a comment for now. So we're going to provide a couple things. We're going to provide a data member attribute, which specifies that this is a field or property that is going to be transported. And we're actually just going to create this as a public, let's see here, we're going to do public string data source. And this will be a get and set, and this will be a public string initial catalog, also with a get and set. And make sure you don't forget your data member attribute on any of these. And we'll have a public string user ID. Okay. And we're actually going to make this a structure. And what we're going to do is, in the service side, we're going to make this an immutable structure. So we're going to provide a constructor, and we'll say connection string, and we'll say string data source, string catalog, string user ID, string password. So to make this immutable, we'll make our setters private. And we actually will probably have to put backing fields because we can't access the instance of the class before, the instance of the structure before everything's initialized to its default values. So if we were to compile our service, now we need to update our interface to return our connection string, and this is actually in. So we need to replace this with our connection string structure. And then what we need to do is we need to go to our stored connection string and do the same thing. As well as our implementation. And then we need to update our private dictionary. Okay. And go to our abstract class and do the same thing. Now to make things really easy, what we're actually going to go ahead and do is go to our connection string class and add a constructor. And we'll just add SQL connection string builder. As a constructor parameter. And we could do the same thing here. We can copy these properties, but this time we can say connection string data source connection string initial catalog user ID, and then lastly connection string password. Okay, let's build. And now we need to update some of our code. So this will be a new connection string builder. Close our parentheses. And like I said, we would need to implement backing fields to our structure because we can't access a property until everything's initialized. So we're just going to make these into private fields. So we'll do private string data source, and then we'll say get return data source, and then private set value. Actually, we can, now that we're making backing fields, we can actually omit the setters completely. Okay. Take that. Get rid of some of these errors. All right. Now we have to change some of the logic. We could make this a mutable class or immutable class, so we can continue to return null, or we could return a system nullable of our structure. What I would actually prefer to do is let's go ahead and make this a class. And then we need to update our unit test mock object. Builder. Okay, add our extra closing parentheses. Okay, now if we build our routing service, all of our changes should compile. Build our routing service tests, and we need to do connection string rename that. Now we can build our test project. And now we can actually go ahead and rerun our test to make sure that it still works. So let's go ahead and build our solution. And we'll run our test, and it should still pass. And it does. All right, so now what we can do is we can close all this. All the changes to our service are done. And now we can go to our service reference. And like I said, anytime you make a change, you can right-click and hit Update Service Reference. Now we need to publish our service first, because that's where we're getting our service reference from. And now we can update our service reference. And now what we should get is, now you can see that our getConnectionString method returns a connection string object. And now we have our working code. So if we run this, go to debug, and we'll run our client. Okay, so an error occurred while receiving the HTTP response. It's going to be due to the service endpoint binding not using the HTTP protocol. Okay, so let's go ahead and let's run our routing service in the WCF test client at this point. Because remember, now we're not returning a SQL connection string builder as a return value. So now we can actually continue to use the WCF test client. So the problem wasn't originally the dictionary, although you cannot, the problem still persists. You can't return a dictionary as a return value in WCF because it's not easily described. So that is still true, but the real root of the problem was that we were returning a SQL connection string builder, which is not serializable out of the box. So what we can do is we can run our get connection string test by double clicking it, And you can see that we can provide some default values. So we're going to do routing service for the username. For the password, it was ABCDE or ABCD1234. For the name, we'll specify default connection string. And the cool thing about this is we're specifying the parameters. We're specifying parameters of type string, and we can hit invoke. And what this will do is it will actually run the service, and we can see that we got the same exact error that we did when we tried to run it from our WCF client. And we can see that it says the service is offline or inaccessible, or the client-side configuration does not match the proxy. Now what we can do is we can go to our service in our web browser and refresh, and we can see that it still shows up. So that usually means that something's wrong with our configuration. Okay, so everything in our application config files looks great. The bindings all match up. There's nothing wrong. So usually what this means is that when you're running your WCF service and you don't get a response, usually it means that something errored out on the server side. So what we can do is we can actually debug our routing service itself. So we're going to go to our stored connection string service, and we are going to hit a breakpoint on our first line here, and we'll just start stepping through the code. And what we'll do is we'll go ahead and set that back as our start project, and we'll go ahead and run this and debug. And we'll go ahead and do it through the WCF test client. And we'll go ahead and specify routing service ABCD 1234, and then we'll specify the name default connection string, and then what we'll do is we'll hit invoke. Okay, so now we can see that there was nothing wrong with actually connecting to our service. So we can see that we have our username, and we have our username here, our password, ABCD1234, ABCD1234. Okay, so it should match, so it should actually bring us down to internal get connection string, which is fine. Now if we go into here, we should actually be able to break on connection strings, which we can see it contains 1. And the key is indeed default connection string. And we can see that it's returning a routing service.connection string object. And we can see that the name we're specifying is default connection string. It should be able to find the key, so it should be able to return that. Okay, so all's good. So we're returning a connection string. Okay. Okay. So all is good. That is returning connection string objects. So if we were to go ahead and run this, and invoke, we can see that we should get our return value. So everything looked like it went well. But we still get the error. So what's happening is it was able to invoke the service, it was able to actually perform all the work correctly, but for some reason we're having problems getting the actual information returned to the client. So what we're going to do is we're going to break in the debugger, and we're going to use IntelliTrace. So we can see that we have a system.serviceModel.serviceError, and we can see that there is no set method for property password in type routing service.connection string. Okay, and this brings a good point about properties in WCF.
Now in WCF, by default, properties need to have both a get and set access method. Now if we go to our connection string class, we can see that we made it immutable out of the box. So we only provided a get method and a private backing field. So to maintain immutability on your WCF objects, we can actually add a private set method. And what will happen is WCF can still work with private sets. And we could essentially remove the backing field accesses completely. And we could set this to the private setter, or we could set the backing field initially. It doesn't matter. But now if we were to build and compile this, so now what we can do is we can actually run our routing service in the WCF test client again, and we should actually get the correct return information back. So we should specify our username routing service, our password, which is ABCD1234, and our name, which was default connection string. And we hit invoke, and we get our return value of our connection string with my server address, my database, password, and username. Now the cool thing about the test client is that you can actually select the XML tab, and you can actually see what was transported over our endpoints and bindings. So we can see that the request, we can see here, uses the SOAP specification, which is just a simple envelope for requests. It defines a container for data, and you can read about that more at the go to MSDN and search up SOAP, and you can read more about that. I'll provide some links to it. We can see that called our get connection string method here on this line, and that we specified our parameters here, and our response was get connection string response, a result, and then here is the actual data of our connection string object. And again, mind you, this is all done in metadata. So the types that are actually created from our service reference are just copies of the original types in the service. All right, so now what we can do is we can go through our project and we can close the WCF test clients that we were using. We don't need those any longer. And we can actually republish our service. And let's make sure that we have it set to release configuration. And now we can actually set our startup project as the routing service client, and we can go ahead and run that debug. And now we can actually make sure that that client code does in fact work. Now you can see that what we did here was the console output the type information routing service client.routing service.connection string. We never overrode the toString method in our object, which actually wouldn't make a difference because through metadata, it's not going to return that information anyway. So what we would need to do in our program.cs file is we can essentially access the properties of the builder object. So we can see that we have the data source object, initial catalog, password, and user ID. So let's run this again, and let's just set a breakpoint so we can investigate the contents of that object. Okay, so we can see that we have the data source property, password, user ID, all that information is there. So what if this brings us to the point of reusing types now? What if in our WCF service, in our connection string object, what if we did in fact override the toString method? So if we overrode toString and we said return, we could actually do a SQL connection string builder equals new, and then you could say builder.dataSource equals data source, and we could say builder.initial catalog, initial catalog, builder.user ID, builder.password, and we can return the builder to string. Now if we were to recompile this, and republish it, and then run our test client again, we can see that we still get the same exact result. And that's because we're working through metadata. The metadata doesn't, the toString method isn't considered an operation contract, so it doesn't gather that information. So what we would want to do is actually create a common library and move our connection string object to that library. So we can actually right-click our solution, and we're going to add a new project, and we're going to make this a class library, and we're going to call this routing service.common. And we can delete the default file in there, and we can actually just click and drag our connection string class to that library, and then delete the old one. And we need to update the namespace, so it's going to be routing service.common. And we need to add references in the class library to system.serviceModel. And also, we need to do the same thing for the data contract attribute. Which is in system.runtime.serialization. And I believe that is its own library, so include that reference there. Now what we need to do is reference our common library from our service, as well as our client. So there's nothing else that we need to do for the routing service.common library. It's simply a storage for our connection string. And now what we can do is we can go in here to anything that references that connection string object, and we can import the new namespace, which is routing services.common. Oops. And let's delete that. And I forgot to reference it in our unit test, so we need to do that as well. And we can close all these documents now and rebuild our solution. And we have one last spot that we'll use it. There we go. Okay, and we can republish our routing service again. And now what's going to happen is now if we go to our bin folder in our routing service in IIS, now we can see that we also have our WCF service library, but now we also have our class library with the connection string object in there. So the common DLL will be used by the service as well as the unit tests as well as the client. So if we run our client now, you can see that we still have the arbitrary information there that we don't need. So what we need to do is update our service reference. So we can right click our service reference and hit configure service reference. And we have this option that says reuse types and reference to assemblies. So we actually need to update our service reference, rebuild, and rerun. And it shouldn't be that way. Figure. We need to also clear up these warnings. mark that down to .NET 4 real quick. And let's go ahead and remove our service reference completely, and we'll re-add it after publishing our routing service. Our address is still there, of course. And we'll reuse the same namespace. Okay. Okay, so now we can see that it added a data source to our connection string class. So now if we were to run this, we should let's see here, we've got some problems. routingservice.com. Okay, so the problem is we have some conflicts with namespaces, so we're going to go ahead and delete our service reference completely. And we're going to re-add it. Again, we can use the same URL. And instead of choosing routing service for the namespace, we're going to actually go with stored connection string service. Okay, and now we do need to go ahead and update the namespaces in our client project again. Now if we run this now, it should build and it should work. Okay, so we can see now that our toString method is being invoked, except now that we have a null reference issue with our connection string builder, we can actually easily solve that with a string empty instead of a null reference. So okay, and I believe that the connection string here looks good. Okay, so let's rebuild all this, republish our service. And run our client one last time. And there we go. So you can see though we do have a problem. We are missing our initial catalog value, our user ID value, and our password. So let's go ahead and investigate what's going on there.
Okay, and the reason that we're getting blank return values for our user ID and password is actually just a simple typo in our private setters. So we need to make sure that we set those accordingly. And the same thing for our initial catalog, actually. All right, so if we rebuild now and republish, and now we can just run this through our client. Now we should have the proper values. So if we investigate the value of the user ID and password, we can see that we have the correct values now. And the correct values are now output to the console window. So in a nutshell, that's the easiest way to create and consume a WCF service. Like I said, the term WCF client is very vague. Basically, it just refers to the actual code that is used to construct the client proxy, which is this class right here. Now, mind you, we're not completely going off of metadata at this point. We're reusing the type connection string from our common library. So the only actually metadata we're using is for the actual service itself. Okay, so in the presentation, let's find our slide here. We covered creating our client, we referenced the service, we've used it. We're not going to unit test the client. There's really not any unit testing required for the client. That was all done on the server side. But now we want to go ahead and talk about dependencies and removing them. So dependencies in WCF are things like the application configuration file as well as the service reference. We actually don't need a service reference at all. And anytime you make a change to your service, you have to update that service reference, and you have to also update the values in your app config file. If you don't want to deploy an application config file to your client, and if you don't want to update a service reference every time something changes, you can actually delete those two completely. And that's what we're going to go ahead and do. So let's go ahead and delete our service reference. And let's actually go ahead and delete our application config file completely from the client. Now we still need information about the routing service, otherwise we can't call the methods on it and use it. So this is done through the iConnectionStringService interface. And what we're going to do is we're actually going to move that to the common library. We're going to delete the old interface in the old project. And again, we're going to update the namespace for that to .common. So now our iConnectionStringService is going to live in the common namespace, and we need to go back and add references anywhere that requires that interface. So first off, in our client, we can delete all of this client code. We're going to rewrite that using the new common interface that we moved over. Okay, and because we're already using our routing service common namespace for a connection string object, we don't need to make any other changes to our unit tests or the actual service itself, because I moved the interface to the same namespace, so it all lives in the same location. So what's left now is to actually create the WCF client using pure code. We're not going to use any application files, anything of the sort. Now we can take a look at our server configuration. We can kind of see the things that we need. We need a basic HTTP binding, so we can translate that into code, which lives in system.serviceModel. And we can just instantiate a new instance of that. Now what we need to do is we actually need to create the endpoint. And this is done using the endpoint address class. And what we need to do is just specify the address to our service. And if we go back and hit add service reference, we can just copy our URL from this combo box, or you can just grab it from the location we used earlier in our web browser. So we can go ahead and paste that address in there. The next thing we need to do is create a channel factory, and as you can read in the description, it creates and manages the channels that are used by clients and servers to send messages. So this is basically just similar to a web client where you're sending and receiving data. And then the type of interface that we need to provide for T-channel is our actual service. So we're going to specify iConnectionStringService, and we're going to call this connection string channel. We'll create a new instance of that, and we're going to specify our binding and our endpoint in the constructor. And now what we can do is we can create an instance of our service by calling connection string channel.createChannel. And now what we can do is we can actually do connection string equals client dot get connection string, and we can see now that that's the only method we can see, because that's the only method defined in our contract. And we can specify our username,
our password, and the name of the connection string. All right. And what we can do is, once we're done with that, we can create an instance of iClient channel, which is an interface that Channel Factory actually implements through the create channel method. And what we can do is we can say channel equals iClient channel, and we could cast our client. And then the reason we're doing this is strictly so we can close it and dispose of it. And now we can go ahead and do the same thing, and we could write our connection string to the console. And if we run this, let's see where we have a build error, and it is on our basic HTTP binding. Oops, I just didn't specify the right name. And we can see that we have the same exact result, except we did it without an app config file, and we did it without a service reference. So that removes the two dependencies in your client library. The only other dependency it does create is you have a third library called routingservices.common in between the two that hosts all your common items. So that is the only other dependency that you have. Now, one other thing that you could do is you could essentially move these dependencies into the client project and reference the service. Reference the client from the service. Like I said, you're communicating over the transport through basic HTTP binding and your endpoint. So there's actually no hard reference from your client or your service to one another. So if you really wanted to, you can move these two objects to your client and reference that from your service to remove the third library. All right, we're not going to do that in this project. However, everything is actually completed, and let's just do a quick republish of the service one last time on our release configuration. All right, and let's go back to our slides and make sure that we didn't miss anything. So we talked about bindings and endpoints. We talked about what is WCF, what are contracts. We even went further and we created a data contract for a composite type. We actually had some problems while creating the service, and we worked those out. We used our own authentication. We unit tested, and we created our client. We did the default out of the box stuff. We skipped the unit testing for the client because it's not necessary. And we talked about dependencies and removing them. So as you can see, WCF is very powerful. It allows you to do everything you want in code, especially code that you're familiar with. And you have very powerful service-oriented communication. There's actually not a whole lot of effort involved in setting up services and clients in WCF. This presentation pretty long because we talked about everything we could, but once you're familiar with it, you should be able to set up basic services in about 5 to 10 minutes. So I will include the source code for download along with the video as well as the presentation files. If you have any questions, let me know. I'll be more than happy to answer them.